Well, this would be like pi over 6, 2 pi over 6, 3 pi over 6, right? So this would be what? 5 over 2. Okay, so we start at 0, the middle is 0, and the end is 0. The amplitude is still 1, but instead of going up and then down, since it's negative, we have to go down and then up. So we'll be at -1, and then we'll be at +1. So this will go like... Okay? Questions? No? Okay. The tangent function. The tangent function, we're not going to worry too much about like the slope of it. You haven't done these? Okay. We're not going to worry too much about like the curve. We're just going to, in general, we're just going to make that shape all the time that you see there. The main thing we need to look at is the period. There is no amplitude because it goes on and on forever. Remember our circle chart, there is no tangent for pi over 2 or 3 pi over 2, so those are the asymptotes. And so there is no amplitude because there's no maximum value. So we're just going to look at the period, which is normally pi. And so again, we're going to divide that by whatever the b is. In this case, it's normally pi. So the the period will be just pi over b instead of 2 pi over b for tangent. And there is no amplitude. Okay, so the other thing about tangent, if you look at the one period for tangent, it doesn't start at 0 normally. The period is pi, but it starts at -pi over 2 and it goes to +pi over 2. So whatever our period is, we kind of have to divide it by 2 and put the half of it on one side of the 0 and the other half on the other side of the 0. Does that make sense? Olivia?
Kinda.
So, okay, so for the standard one, the period is pi. So we take that and divide it by 2. And then we start at -pi, so the range, or the period, I guess, goes from -pi over 2 to +pi over 2. So half of it is on the negative side and half of it is on the positive side. So whenever we get our period for this, we'll have to take it and divide it by 2, and then half of it will go on the negative side of the 0 and half of it will go on the positive side. So for the first example, y equals 2 tangent of 3x. This number, we're not really going to worry about at all. It would tell you something about like the slope of that curve, but we're not going to be too particular about that because it's very difficult to get to the nitty-gritties on that. So we're going to have this, but we do need to figure our period, which is going to be what?
3.
Pi over 3. So to figure out where we start, we have to divide that by 2. So what's pi over 3 divided by 2?
2 pi over 3. Or just kidding. 2 pi over 6.
Just pi over 6, right? So it will go from negative pi over 6 to positive pi over 6. Are we good on that? Yes, okay. So it'll start at negative pi over 6 and go to positive pi over 6. Let's erase that. And those will be the asymptotes. And then we'll just draw that thing. And it will go through 0, 0. That will also continue, like you can see on the graph that's given to you there. It will continue in both directions, but that would be one period of it. Right? Okay. What about the secant, cosecant, and cotangent?
I don't think we did those.
If you didn't do tangent, I'm guessing you probably didn't do those either.
No, we did not do these.
And I'm not really wanting us to become experts at all of this. I just want you to have a basic understanding of all of it before we go into the calculus of it, so that when we talk about things in calculus and they relate back to this, then you have something to relate it to, right? Because none of this, what we're doing right now, is really calculus. It's all trig. Okay. So, secant is the inverse cosine, or 1 over the cosine of x, and tangent is sine over the cosine of x. They both have vertical asymptotes at the same x values, since both of them have cosine in the denominator. And so when the denominator is 0, that's when we'll have an asymptote. So for the secant, just like the cosine, the period is 2 pi. For the, it doesn't talk about the cotangent, or the tangent. It doesn't give you a graph of the tangent, but, oh no, they're just talking about secant, because we have the tangent on the other side. Okay, right. So, but again, the asymptotes will be the same as for tangent, so they'll be at the intervals of the pi over 2. And the period is the same as for cosine, which is 2 pi. And again, there's no amplitude. Since we have asymptotes, there cannot be an amplitude. So the secant will look like that you see there. They show you also the cosine, so you can see it would like have minimum and maximum points at 1 and -1 and go up from there and then down. And the cosecant and the cotangent will both have vertical asymptotes at the same x value, since they will both have sine in the denominator at the same time. Cosecant period is the same as sine, which is 2 pi, and cotangent's period is the same as the tangent, and that is period pi. And again, none of those will have amplitudes either, because they have asymptotes. Okay? Alright, let's stop me talking and you listening and start just practicing some, okay? And we didn't do any examples of those cosecant, secant, whatever, so if you get to one of those, we can talk about it, but the first 3 are sine, cosine, and tangent on this. So why don't you do those and then we'll talk some more. Perhaps this was too much information for one day. Sorry.
Cosine and cosine ones are both. end?
Well, that's where one, like, on the board when I was drawing them, I only drew one period, but it will continue forever, so you would continue doing that same thing that you did for one period.
So how do we know like where to draw the first up dot? Like I know the amplitude, but how do you
Isn't
know
it
where
just
it's
like
supposed to go?
half
It
of
would
it?
go halfway, yeah, halfway
Okay.
between.
Isn't the amplitude just 0.5?
Mm-hmm.
So
Oh.
it's like barely anything.
I put it. So this one is 2
The cosine starts at
They're so ugly. Tangents don't have amplitude, it's just
2 pi over 2. So pi divided by 2.
pi divided by 2.
We find it like we usually do, and then we have to divide by 2.
Oh. So those are the asymptotes. It doesn't show it on the other side.
I just think 3 pi over 2.
This one's the asymptote.
So we go over 2.
What did you do? That's what I thought.
Number 3, where do we make the other asymptote?
Where do you have one asymptote?
Pi over 2.
Well, okay, so the period is pi over 2. So remember with tangent, we have to do half of that before the 0 and half of that after the 0. So what's half of pi over 2?
Well, we did the period is pi, and then we divided that by 2.
Right, the period's pi over 2, but
It is.
the period of the tangent is pi over 2, but that's not where the asymptotes are. Because you have to have half of the period is to the left of the 0 and half of it's to the right of the 0.
Like we found the period like 2 pi over 2 and we simplified it to pi.
For
And then-
tangent, the regular period is pi.
not
So
2
it's
pi.
just pi over 2.
Okay, that makes sense. So then we divide that by 2?
Yes.
Okay.
So then it's pi.
So pi over 4 would be the first asymptote.
Where is pi?
It's not marked on there, but it would be halfway between the 0 and the pi over 2. And if you guys have done 1 through 3, you could do the periods for the rest and the amplitudes